Dear students, in this lecture we are going to find. So first of all, we will discuss that what is wave function, what is wave function. So in order to define the wave function, that what is wave function, we will take our start with the classical mechanics. In classical mechanics, you know that there is the Newton's second law. Newton's second law which governs all the phenomena in the case of classical mechanics. And here we have the important parameter in the case of classical mechanics is the position of the particle. And you know that the position of the particle is represented by the x. So in order to define the particles, in order to localize, in order to specify the particle in the case of classical mechanics, first we need to define what is x, what is the position of the particle. First we know the position, then we can find out in the Newton's second law, we can find out the acceleration, we can find out the velocity, and velocity, you know that it's a dx by dt, and then acceleration. Acceleration is the double derivative of x with respect to t. And so in this way we can find out all phenomena. First we need to know about the position of particle. But when we comes towards the quantum mechanics, and in quantum mechanics, the quantity with which we concern is the wave function. The wave function is can be represented by psi. So just like in the case of classical mechanics, we have the position. In the case of quantum mechanics, we represent the particle by wave function, which is represented by symbol psi. So psi itself has no physical meaning, no physical interpretation. Psi is nothing but the square of its absolute magnitude, that is psi amplitude square. It evaluates can be evaluated at particular place at particular time. It's proportional to the probability of finding the particle. So psi self is nothing, it's but absolute amplitude square, which is proportional to the probability of finding the particle at particular time at particular space. A position is can be defined by this quantity. So this is important. It is called as the probability. So in the all other quantity like angular momentum, linear momentum, kinetic energy of the body, all other quantity then can be established from the psi. So important thing in the quantum mechanics is first to need to define the psi wave function of the body. So as the probability, the most important term here, instead of probability we use the word probability density. This is the probability density for finding the particle. So this amplitude square is proportional to the probability of finding the particle, and this one is equals to product of psi and its conjugate psi is steric. So psi is a complex quantity, so the wave function can be represented by, like we can write psi is equals to a plus iota b, then its complex part, a conjugate, will be equals to a minus iota b. So its probability, now can find out the probability by multiplying, that is the product of psi and its conjugate. This is equals to psi amplitude square, that is the probability density. It will be equals to a square plus b square. So psi itself is a complex, it has a complex conjugate, it's a complex quantity, but the psi amplitude square is always positive real number. Its probability of finding is always positive and real quantity. So as it is the probability of finding the particle in a certain specific space at certain time, so its integral psi amplitude square into dv, it must not be the infinite, so it must be the finite. So it means that the particle is there. There is the probability of finding the particle somewhere. So it must be the finite, it must be the convergent, so it must not be the infinite. So if this integral psi amplitude square dv is equals to 0, if it is equals to 0, then it means that the particle does not exist. It means that the probability is 0. It means that particle does not exist. So if in order to find the particle, that particle is there, then this integral must be a finite. So it is usually convenient to have psi amplitude whole square to be equal to the probability density p of finding the particle somewhere. So if amplitude square is equals to probability p, probability density p of finding the particle, then this wave function must be normalized. So minus infinity to infinity psi amplitude whole square dv is equals to 1. So it must be this particle exists somewhere at all time. This is also called as normalization condition. So this is also called as normalization. So every acceptable wave function can be normalized by multiplying it by an appropriate constant. So every wave function must be normalized in order to represent the particle. So for particle to represent the position of the particle, beside being normalized, there are certain conditions which must be fulfilled by the wave function in order to represent the particle, and these conditions are, and so beside being normalized, this number one, in order to represent the state of the particle, psi must be continuous. Psi must be continuous, and this is another condition, and it must be a single valued. So psi must be single valued at particular place and at particular time, because the probability can have only one value at particular space and at particular time, and its partial derivative of the psi with respect to x, is derivative with respect to y, and partial derivative with respect to z. So these must also be the continuous, and they must be single value. So this condition is by when we consider the momentum. So psi must be, another condition is that the psi must be normalized in order to represent the particle. It must be normalized. It means that psi must go to 0. Psi must approaches the 0 as x approaches plus minus infinity and y approaches plus minus infinity. So it must be normalized. So it means that in order, if the psi dv is the psi amplitude, it means that psi amplitude whole square dv, this integral all over the space must be a finite constant. It must be a finite constant. It must be a normalized. Okay, it must be a normalized. For example, if this is the wave function, if it is not normalized, as we go from here, if we go to plus minus infinity, from here we go plus minus infinity on both sides. If we go to plus minus infinity, even in the z direction, if we goes to plus minus infinity, then there will be the no wave function at all, that is psi is equals to 0. If it is not normalized, then it means that this integral must be a finite constant. It must be the normalized in order to represent the state of the particle. So by considering these conditions, we can write the probability P of finding the particle between x1 and s2. It will be equals to psi amplitude whole square dv. That this is the probability of finding the particle between x1 and x2. So this was all about the description of the wave function, that what is the wave function and what are the necessary conditions which must be fulfilled by the wave function in order to represent the state of the particle. Thanks for watching. For more videos, please subscribe our channel.